Prudent Scholars in association with Goa Headmasters Association.
Hello students, welcome to your science class. In today's class, we will be learning a new lesson called as carbon and its compound. Carbon is not a difficult element to spot in your daily life. For instance, the pencil that you use is made up of graphite, which is also a form of carbon. The furniture that you use in your house is also constitutes of carbon. Carbon is a versatile element which forms the backbone also of many biomolecular compounds. You may not know, students, that 18% of your body weight is also made up of carbon. Okay? So you see, carbon is such an element that occurs in various forms in nature, and it also forms a backbone of many organic compounds. So you can see here I have shown three pictures which shows how carbon occurs in various forms. First one you can see is charcoal, that you know is being also used as domestic fuel, is also being used in barbecues. Then you can see timber, wood, okay, the major constituent of wood is also carbon. And you can see diamond. So this diamond is a form of carbon which forms due to high temperature and immense pressure. So carbon occurs in various forms, from your medicines to your body, constituting of RNA, DNA, various protein molecules. Okay? So the base of all these molecules is carbon. Now what makes carbon so special? First of all, we will learn about bonding in carbon. Okay? Now carbon forms a covalent bond. Now what exactly is covalent bond? A covalent bond is formed by equal sharing of electrons, okay, electron pairs between two atoms. So you can see over here, we know that the atomic number of carbon is 6. Carbon is a non-metal, okay. In your 9th standard, you have learnt about the electronic distribution of carbon, okay. So the electronic configuration is 2 in its first shell and 4 electrons in its last shell. So you can see it requires 4 electrons to achieve the inert gas electronic configuration, but carbon cannot form ionic bond. Now what is required to form an ionic bond? Okay, either there has to be a transfer of electrons in the formation of ionic bond, and we have learnt it that an ionic bond is formed between a metal and a non-metal. Though the octet of the carbon is not complete, but you can see that it is not capable of forming ionic bond. What can be the reason behind it? There are two major reasons. Now first case you can see over here. So carbon could gain 4 electrons forming C4 minus anion, but it would be difficult for the nucleus with 6 protons to hold on to 10 electrons. You already know in the second shell of the carbon there are 4 electrons which are present, the 4 valence electrons. Now if the carbon gains more 4 electrons, the total number of electrons combined from the first and the second shell will be equal to 10. Now 10 electrons will be too much, okay. So the nucleus will be unable to hold on to 10 electrons. So that is the reason, one of the reasons why carbon does not form ionic compounds. The second reason is that the carbon could lose 4 electrons to form a cation, but in order to remove those 4 electrons from the outermost shell of carbon, immense amount of energy has to be supplied, okay. So it would require a large number of energy to remove those 4 electrons. Hence carbon cannot form an ionic bond. So how does it form a bond? So this problem of forming a bond is overcome by sharing its valence electrons with other carbon atoms or with atoms of other elements, okay. So there are different types of covalent bonds that are formed by carbon. Single covalent bond, when a single pair of electrons are shared between 2 atoms in a molecule. For example, fluorine, chlorine, hydrogen, you see the bond between these 2 atoms are all single. That means they are sharing a pair of electrons. Each atom shares 1 electron, thus resulting in the formation of a single covalent bond. In case of double covalent bond, okay, examples like oxygen, carbon dioxide, these molecules are forming double covalent bond because in this case they are sharing 2 pairs of electrons. Whereas in case of triple covalent bond, 3 pairs of electrons are being shared. So what exactly are covalent bond? Okay, so basically the electrons which are shared between the two atoms, okay, whether the two similar atoms or two different atoms, okay, when there is a mutual sharing of electron pairs, okay, that leads to the formation of covalent bond. So let us have a look at the electron dot structure. The electron dot structure provides a picture of bonding in the molecule in terms of the shared pairs of electrons and octet rule. So you know the octet rule states that there has to be 8 electrons in its outermost shell so that the atom gains its stability. Here is an example of formation of hydrogen molecule. What is the atomic number of hydrogen? Atomic number of hydrogen is 1. How many electrons are present in hydrogen? There are 1 electron. So you can see students over here, the dot, okay, the dot represents an electron. So basically electron dot structure is showing you how exactly covalent bonding occurs. Okay, so there are 2 atoms of hydrogen over here. When these 2 atoms of hydrogen share their individual electron, you can see a pair of electron is being shared. Since one pair of electron is being shared, it results in the formation of a single bond between the 2 hydrogen atoms. Now let us see how oxygen molecule is being formed. We know that the atomic number of oxygen is 8. The electronic configuration is 2,6. You know that the valence electrons is 6. So we have written valence electron as 6. So now what we will do? Okay, we will write the structure of the symbol of oxygen and we will try to distribute the electrons. How many electrons are there? There are 6 electrons. So we will represent in the form of, I will represent it in the form of cross lines. Okay. So 1, 2, 3, 4, 5, 6. This is one atom of oxygen. Okay. Then we have another atom of oxygen. So 1, 2, 3, 4, 5 and 6. But you see that for the octet rule to apply, we require 8 electrons. So what will happen? These oxygen atoms, they are going to combine, okay, by sharing the electrons. So when they share the electrons, what we are going to get? Okay. So you can see over here, oxygen has shared 2 pairs of electrons. Now since it has shared 2 pairs of electrons, we can count if the octet rule is being followed. So we are having 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the other atom 1, 2, 3, 4, 5, 6, 7, 8. So the 2 atoms of oxygen have shared their 2 pairs of electron, resulting in the formation of a double bond. Okay. Now let us take another example. So we are going to learn about formation of nitrogen molecule. The atomic number of nitrogen is 5, okay, and the electronic configuration is 2, 3. As per the octet rule, the outermost shell should have 8 electrons in total. So let us try to distribute the electrons. Okay, so 1, 2, 3, 4 and 5. Okay. This is one atom of nitrogen. The second atom of nitrogen, again we are having 1, 2 and 3. Fine. So what will happen? These 2 nitrogen atoms, they are going to share their electrons in order to fulfill the octet rule. Okay. So you can see over here the overlapping of circles. We will try to count the number of electrons now over here. We are having 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 electrons for one nitrogen atom and the other one 1, 2, 3, 4, 5, 6, 7 and 8. So you can see in case of nitrogen, there are how many electron pairs that are being shared? There are 3 electron pairs that are shared. Now since there are 3 electron pairs that are being shared, it will result in the formation of a triple bond. Clear to all of you all? Okay, now let us learn about the formation of carbon dioxide molecule. We know that the atomic number of carbon is 6. The electron distribution will be 2, 4. Okay, the number of valence electron that we have are 4. The atomic number of oxygen is 8. The electron distribution will be 2, 6. Hence, the number of valence electron is 6. Now, let us see how carbon and oxygen combine together. How do they share electrons in order to form a carbon dioxide molecule? Okay. So, we are having carbon which is having 4 valence electrons. So, we will try to distribute it mutually. Okay. And oxygen is having 6 valence electrons. So, 1, 2, 3, 4, 5 and 6. Okay. Again we will write over here oxygen 1, 2, 3, 4, 5 and 6. So, carbon and oxygen, they are going to share their pairs of electrons, which I will show with a colored chalk. So, you can see over here. Okay. So, let us now count the total number of electron pairs that are being shared. Over here there are 2 electron pairs shared between carbon and oxygen, and over here also there are 2 electron pairs shared between carbon and oxygen. So, the type of molecule that it results is C double bond O double bond O. So, what we have done, students, first we have written the atomic number of carbon, we have written the electronic distribution followed by the number of valence electron. We have distributed the valence electron symmetrically around the symbol of the carbon and oxygen atom. So, you can see around carbon atoms we are having 4 valence electrons, and around oxygen atom we are having 6 valence electrons. So, the oxygen atom and the carbon atom, they mutually share their electron pairs, resulting in the formation of double bond between carbon and oxygen atom. So, this is how carbon dioxide molecule is being formed. So, we have seen the types of covalent bond that are being formed. We are having 3 types of covalent bond. A single covalent bond which is formed by sharing of a pair of electron. Then we have double covalent bond which is formed by sharing of 2 pairs of electron, and then we are having triple covalent bond which is formed by sharing 3 pairs of electron. So, then we have seen examples. For example, fluorine is formed by, there is a single bond between 2 atoms of fluorine, then we are having hydrogen, then we are having chlorine. Okay, so all these molecules are formed by sharing of one pair of electron. Okay, then we have learnt examples of double bonds. So, oxygen atoms, they are formed by sharing 2 pairs of electron between them, and the triple bond like nitrogen, which are being formed by sharing 3 pairs of electron between them. Okay. Next, let us see the formation of methane molecule. The atomic number of carbon, as we have already known, is 6. Okay. So, the number of valence electrons that we have are 4, and the atomic number of hydrogen is 1. So, the number of valence electron is also 1. So, you can see in the given picture, students, carbon, okay, it has 1, 2, 3, 4 electrons, and hydrogen is having 1 electron. Each hydrogen atom is having 1 electron. Okay. So, carbon shares its electron with hydrogen, and also hydrogen is sharing its electron with a carbon. So, you can see individually 1 pair of electron is being shared between carbon atom and hydrogen atom, resulting in the formation of single bond between carbon and hydrogen. Next example, as we have already learned, that is the formation of carbon dioxide molecule. You can see carbon having 4 electrons around it, and oxygen sharing its 2 electron pairs around it. So, total it results in the formation of double bond between carbon and oxygen atom. Now, next very interesting topic that we are going to learn is called as allotropes of carbon. Now, what exactly is the meaning of allotropes? Okay. So, basically it is the phenomenon in which The element exists in two or more different physical states with similar chemical properties. So basically appearance wise, okay, appearance wise the molecule or the substance that you see may differ, but the chemical composition of it is the same. For example, you take graphite and diamond, okay. Graphite is opaque, diamond is highly lustrous, transparent, but the chemical composition of diamond as well as graphite, it consists of carbon. So this phenomena in which the element exists in two or more different physical state with similar chemical properties are called as allotropy. Now carbon has three main allotropies, okay, that is diamond, graphite and fullerene. So these are the crystalline varieties that we are going to learn about. So let us first see what are the properties of diamond. So if you have seen diamond, you know diamond jewelries, okay, diamond is used in ring, diamond is used in necklace. Besides its usage is ornamental use, it also finds a very wide application in metallurgy because it is one of the hardest substance known, okay, and it can easily cut the metals, it can cut the rocks. So it finds very important use in metallurgical industry as well. Now when we talk about the structure of diamond, in this carbon, an atom is bonded to 4 other atoms of carbon forming 3-dimensional structures. It is the hardest substance known and it is a very good insulator, and it is used for drilling rocks and cutting, and it is also used for making jewelry, okay. So let us look at the structure of diamond, okay. Remember student, this is just a part of a structure, it is a gigantic molecule, okay, and this picture that you see on the screen, it is just a part of the molecule, okay. So over here you can see, let us take this black dots as our carbon atoms, okay. So you can see one carbon atom is linked to 4 other carbon atoms. So you can see 1, 2, 3, 4. Okay, again let us take some other atom. Over here also you can see, let us take this one, this is your carbon atom. This carbon atom is linked to 1, 2, 3 and 4th. So in case of diamond, okay, the carbon is bonded via its by sharing its electron pairs to more other carbon atoms, to 4 more other carbon atoms. Fine. So this was about diamond. Now let us look at the structure of graphite. Okay, in graphite each carbon atom is bonded to 3 other carbon atoms, and it is a good conductor of electricity and used as a lubricant. Now what is the reason? We learnt about diamond, that diamond is a very good insulator, and when we are talking about graphite, we are saying it is very good conductor of electricity and it is being used as a lubricant. So see, even though the chemical composition of graphite and diamond is same, their physical appearance is different and also their properties are changing. So if you look at this structure of the graphite, this is a part of the network, you can see they are in layers. Unlike the structure of diamond, which was very close and compactly arranged, the structure of graphite, you see they are in layers. So what happens, why it acts as a lubricant? Because of its structure. The structure is such that they are easily going to glide over each other, making it a very good lubricant. Fine. So you can see over here, one carbon atom, okay, in case of, you can see there are ring shaped structures over here, and you can see over here if I take this particular carbon, okay, this black dot, over here it is connected to 1, 2 and 3 electrons. We know that carbon is tetrahedral. So if carbon is tetrahedral, where is the 4th electron? Because the 4th electron is not involved in bonding. Now since the 4th electron is not involved in bonding, that is the reason why there is a movement of this 4th electron, making it a very good conductor of electricity, unlike the atom of diamond in which all the 4 electrons were involved in bonding. So we already have learned that for the conduction of electricity we require the movement of ions or the movement of electrons. In case of diamond, there is no movement of electrons because the atoms that you can see over here in case of diamond, okay, each carbon atom is linked to the other atom. So there is no availability of that vacant electron. But in case of graphite, only 3 electrons are involved in bonding and the 4th electron is available for the conduction of electricity. So you see how different they appear and how different are their properties even though the chemical composition is the same. So here we can see the difference between, so you can see diamond, which is also a rock formed under immense pressure and temperature, okay, and this is the picture of graphite that you see. One is transparent, shiny, lustrous, okay, which is having a very high value and one of the hardest substance known. While we talk about graphite, it is opaque, it is dark in color, okay, it is not hard, it is soft and it is slippery, that is why it is being used as a lubricant. And then if you see the structure of the two, okay, you will see the three-dimensional network of diamond, how closely, compactly they are being arranged, while if you see the two-dimensional network of graphite, they are arranged in layers and only 3 electrons are involved in bonding. So if we talk about the difference between diamond and graphite, one point we will talk about its appearance. One is lustrous, the other one is opaque. Diamond is used as a very good insulator, whereas graphite is a very good conductor of electricity. Let me also inform you students, diamond is a very good thermal conductor. Whereas there are some varieties of graphite which are also used as thermal conductors, especially to make the fire shields. Okay, and the next difference that we talk about is the nature. It's very hard and the other one is soft. Okay, so these are some of the basic difference that we know about diamond and graphite. Now let us look at the third allotrope of carbon. Okay, so the name, as you can see, it's called as a Buckminster fullerene, and the first thing that you see when you look at it is the picture. Okay, it appears like a soccer ball. Okay, so Buckminster fullerene, it contains a cluster of 60 carbon atom, okay, and that is why it is also called as C60. And these atoms are joined together to form a spherical molecule, and it is a dark solid at room temperature. Now about Buckminster fullerene, if you look at the structure, it is a closed caged structure. It consists of hexagonal faces and it consists of pentagonal faces. There are 20 hexagonal faces in Buckminster fullerene, while there are 12 pentagonal faces, okay, and it is one of the most widely used allotrope of carbon. It finds its application in medicine. Now how it finds the application in medicine? It is used as an antioxidant. Now what is happening over here in case of Buckminster fullerene? It is used as an antioxidant because it has the ability to, it has the affinity to attract the free radical, which makes it a very important usage in the medicinal field. Okay, it also finds its applications in electrical field, like it is used as semiconductors, superconductors. Okay, so Buckminster fullerene is also used in industry as very high tensile fibers. So you see students, these allotropes of carbon that we have learned, they find such wide variety and such wide applications in our day-to-day life. Next, let us learn about the versatile nature of carbon. Now, why is carbon present everywhere? So, for instance, when I began my class, I told you that carbon, the furniture that you are using, or the pencil that you are using, the plastics that we use. In fact, our body, 18% of our body by weight, because our body is made up of proteins, and the basis of proteins is what? It's carbon. So, carbon is very versatile in nature. Okay. Even oxygen is present in a large amount, but why is oxygen not finding that much use compared to carbon? That is because of its special properties, that is catenation, tetravalency, and its formation of covalent bond. Now let us learn in detail what exactly is this unique property of carbon that is making it so versatile. Versatile means what? It is everywhere. You name, it's present in plants, it is present in animals, our bones consist of carbon. So that is why we call it as an organic substance. Okay, I am not talking about carbon monoxide and carbon dioxide, they are inorganic forms. When I am talking about organic forms, I am talking, you know, when its bases are made up of proteins. Okay. So the existence of large number of organic compound is due to the following nature of carbon. First is catenation, which is also called as a self-linking property of carbon. So let us see what exactly is catenation. The self-linking property of an element, mainly carbon atom, through covalent bonds to form a long, straight, branched and rings of different sizes are called catenation. Now, why this self-linking property arises in carbon and not any other element? There are also many other elements. For example, even sulfur shows the property of catenation. But what makes carbon so unique? It is because the size of carbon atom is small. Okay, the size of carbon atom is small, and the second is the great strength of carbon bond. Okay, the carbon-carbon bonds are very stable in nature, this is one reason, and the second reason is the size of the carbon atom is very small. Due to its small size, okay, and it will easily become stable when it combines with other atoms or the atoms similar to itself. Okay, so let us see example. So we see over here carbon can form stable multiple bonds. We have learned three types of bonds: single bond, double bond and triple bond. Okay, so carbon forms stable multiple bond, that is double or triple, with itself and with the atoms of the element. So first one you can see, the first picture you can see, okay, the carbon is linked to hydrogen atom and all are linked via a single bond. Okay, so you see the link between carbons, 1, 2, 3 carbon atoms are there and they are linked via a single bond. And then we see hydrogen atoms which are connected to carbon, that is the bond between carbon and hydrogen is single bond. Okay, this is propane, this is another example, that is butane. So this kind of structure is called as a straight chain structure. Now in the second case, if you look at the structure carefully, there are no straight chains, of course they are, but linked to that is another substituent, okay, which is causing branching. Okay, so this is a branch chain that you can see, 2-methyl propane, 2,2-dimethyl propane. So carbon's ability to form multiple bonds allows it to form structures like straight chain, branch chain and also ring. So now let us move on to the ring structures. So if you look over here, there are two types of compounds that you can see. Okay, over here let us move on. Okay, here you can see carbon is linked to each other, okay, and it has formed a closed structure. Okay, this structure is called as cyclobutane. Whenever there is a formation of ring structure, the term that we use is cyclo followed by the word root. Okay, so over here you can see cyclobutane, 1, 2, 3, 4 carbons are there, all are attached via single bonds, and over here you can see another closed ring structure, that is cyclohexane. You can see there are 6 carbon atoms, 1, 2, 3, 4, 5 and 6 carbon atom. And remember students that carbon has to follow tetravalency. So each carbon is bonded, okay, there are 4 bonds around a carbon atom. So 1, 2, 3 and 4. So each carbon is attached to 2 other carbon atoms and it is attached to 2 other hydrogen atoms. Next we will move on to the tetravalent nature of carbon. So carbon has valency of 4. What is the meaning of valency? Valency is the combining capacity of an element. Okay. So we know there are 4 valence electrons and by sharing those 4 valence electron it is going to combine with other element, and this combining capacity of an atom is called as its valency. So it is capable of bonding with 4 other atoms of carbon or some other heteroatoms with single covalent bond as well as double or triple bond. So carbon will either link with itself or it will link with other atoms. So when I say other atoms, that is the term that is used, that is heteroatoms, okay, and it is capable of forming single, double or triple bond. So here are few examples that you can see. This is chloroethane. Okay, all are linked via single bond. Then over here there is ethanol and then there is ethanol. So if you look at the structure of ethanol, there is a double bond between carbon and oxygen. Okay, we will be learning about the functional group in our next class, but let us continue with this. What you have to remember in this particular part is that carbon is tetravalent in nature. It is going to have 4 bonds around it because it will share electrons with either itself or with other atoms, resulting in the formation of a wide variety of compounds. So now let us move on to hydrocarbons. Now what are hydrocarbons? These are widely found compounds. Compounds containing of carbon and hydrogen are called as hydrocarbons. Now you can see over here, hydrocarbons are of three types: saturated hydrocarbons, unsaturated hydrocarbons and aromatic hydrocarbons. We are going to learn each one of them in detail. So let us begin with saturated hydrocarbons. Now remember students, saturated hydrocarbons are also called as alkanes. Now those compounds which are linked to each other via a single bond, okay, are called as alkanes. Okay. So the general formula is CnH2n plus 2, wherein N stands for the number of carbon atoms. Now in this, the carbon atoms are connected by only a single bond. In case of alkanes, the carbon atoms are connected via a single bond. So you can see over here there are examples given: methane, ethane, propane. Okay. In case of methane, we have already seen the electron dot structure of methane. There are 4 hydrogen atoms and the formula is CH4. In ethane, we are having 2 carbon atoms and 1, 2, 3, 4, 5, 6. Now how? If we use the general formula, okay, how will it become C? How many carbon atoms are there? There is 1 carbon atom. H2n plus 2. So for hydrogen, when we multiply 2 into 1 plus 2, we are getting how much? 2 plus 2 will be 4. So we are getting CH4. The second example we are having ethane, C2. So instead of N, if I write 2 over here, okay, H2N. So since the number of carbon atom are 2, I multiply 2 into 2, I am getting 2 2s are 4, plus I add 2, I am going to get 6. That is how the formula becomes C2H6, and in case of propane I am getting C3H6. So let us work it out with the help of the general formula, the molecular formulas of various alkanes. Okay, first we will see if I am having 2 carbon atoms. Okay, so if I am writing, so my N is equal to 2 in the first case. So what I will do, 2 multiply by 2, wherever there is N I have written 2 plus 2. So what will be my formula? C2, H2 2s are 4 plus 2 I am going to get C2H6. Okay, so this is my formula for ethane. If I am taking N is equal to 3, okay, then my carbon, the number of carbon atoms that I have are 3. Hydrogen, we see the general formula is written 2 multiply by N is equal to 3. So I am going to write 3 over here plus 2. What will I get? The formula that I will get is C3, 3 2s are 6, 6 plus 2 is 8. So C3H8, which is the formula for propane. Okay, if I take N is equal to 4, I am going to get C4, H2 multiply by 4 plus 2, my formula is going to be C4H10, which is my butane. So if you see carefully, if you look at the names of all these compounds, they are ending with N, A and E. That is why saturated hydrocarbons are also called as alkanes. So if the compound is having only single bond, its name is going to end with A and E. The you can see over here in this example, ethane, propane, butane. So this is the example of our saturated hydrocarbons or alkanes which are connected by single bond. Now let us learn about unsaturated hydrocarbons. Now those hydrocarbons which constitute of double or triple bond are called as unsaturated hydrocarbons. So in the first case we are going to talk about double bond, that is alkenes. Okay. So general formula is CnH2n, where N is the number of carbon atom. Now in this the 2 carbon atoms are connected by double bond. So there is a double bond between the 2 carbon atoms. Okay. So over here if you see there are 3 examples, ethene, propene and butene. In this nomenclature you see they are ending with E and E. So ethene or also called as ethylene, propene and butene. Okay, this is PROPENE. Fine. So over here you can see there are 2 carbon atoms. The 2 carbon atoms are linked by a double bond. Over here again there is a double bond between 2 carbon atoms, and even in the third case there is a double bond between 2 carbon atoms. So alkenes are those in which the 2 carbon atoms are connected by a double bond with a general formula CnH2n. What about alkynes? Alkynes are ending with YNES. The general formula over here is CnH2n minus 2. Alkanes is CnH2n plus 2 and alkynes is CnH2n minus 2. Okay. So in this the 2 carbon atoms, what kind of bond are there? The type of bond that we are having between the 2 carbon atom is triple bond. Okay. So here we have seen types of hydrocarbons, saturated and unsaturated hydrocarbon. Saturated hydrocarbons also called as alkanes. Okay, they are made up of single bond, and unsaturated hydrocarbons are called as alkenes or alkynes. The 2 carbon atoms are bonded by a double or a triple bond. So now let us look at the electron dot structure of simple hydrocarbons. The first one that you can see is methane. Okay, the atomic number of carbon is 6. There are 4, the cross, the X what you can see, those are the electrons of carbon, and the dark dot that you can see are the electrons of hydrogen. So you can see in the first case students, hydrogen is sharing its 1 electron, carbon is sharing its 1 electron. Okay. The bond between carbon and hydrogen that is formed is a single bond. Okay. So here there is only 1 carbon atom, but in the next example that you see, okay, there is a C that is missing over here. Okay. So in over here also there are 4 carbon atoms. The valence electrons are carbon atoms are showed via cross, and the valence electrons of hydrogen atom are shown with a dark dot. So if you look at the structure over here, the bond between 2 carbon atom is a single bond. That means they have shared 1 pair of electron, and around it we are having hydrogen. Again they have shared 1 pair of electron each. Okay, that is the example of ethane. So these are the electron dot structures of simple hydrocarbon. Okay, so you can see in case of alkenes, it is double bond and the compounds end with, the names of the compound end with in. In case of alkyne, it is a triple bond and the names of the compound end with -ine. Okay, so there is a double bond between 2 carbon atom. The general formula of alkenes is CnH2n, and the general formula of alkyne is CnH2n minus 2. So if I am having 2 carbon atoms, what will be the number of hydrogen atom? N stands for the number of carbon atoms. So 2 multiplied by 2 I am going to get 4. So what I am getting? C2H4. Okay. So C2H4 is your ethene, and the structure of C2H4 is C double bond C, okay, with, you can see 2 carbon atoms, 1, 2, 1, 2, and how many hydrogen atoms? 1, 2, 3 and 4. So C2H4 is your molecule, okay, and the bonding between them is a double bond. That is why the name is called as ethene. In case of alkynes, we see it is, if I am taking C2, how many hydrogen atoms will I have? 2 multiplied by 2 I am going to get 4, 4 minus 2 I am going to get 2. So if I write down the structure of this, I am going to get C triple bond C, okay, H and H. So how many atoms of carbon I am having? 1 and 2, and how many atoms of hydrogen? 1 and 2. So my formula is C2H2 and the name is ethene. Fine. We will be learning about the nomenclatures of this. So as of now you just remember about the bonding, the general formula, okay, and how exactly the molecules are being formed. Don't worry about the nomenclature, we will be learning in the next session. Fine. Okay. Now the next important property of carbon is isomerism. Now what do you mean by isomerism? Now carbon compounds which are having the same molecular formula, but if they are arranged in a different pattern, we call that property as isomerism. So over here you can see the molecular formula is C4H10, that is called as butane, and butane is having two isomers. In the first one you can see it is a normal butane or N-butane. Let us count the number of carbon and the number of hydrogen atom in both the cases. In the first case we are having 1, 2, 3, 4. So C4, okay, and in the second case 1, 2, 3, 4. But if you look at the two structures, you will see in the first case it is being arranged in a straight line, okay, or in a straight chain. And in the second case it is being branched, it is having a branched chain. But the number of carbon atoms in both the cases are 4. Now you look at the number of hydrogen atoms. Let us count in case of N-butane, we are having 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we are having 10 hydrogen atoms in N-butane, and in the second case we will see 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And in the second case also we are having 10 hydrogen atoms. Now if you look at both the cases, the molecular formula of butane or N-butane and isobutane is same, C4H10. But if you look at the way it is being arranged, in the first it is arranged in a straight chain and in the second it is arranged in the branch chain. So this is the property of carbon which is called as isomerism. So over here we are having a second example, that is of pentane. Okay. So pentane we are having formula C5H12. So let us see in both the cases if we are having 5 carbon and 12 hydrogen atoms. So we will see 1, 2, 3, 4 and 5 carbon atoms in N-pentane or normal pentane. In this branch structure we see how many there are 1, 2, 3, 4, 5, and in the third structure also we are having 1, 2, 3, 4 and 5. So in all three structures we are having 5 carbon atoms. Now the hydrogen atoms, how many we need? 12. So let us count in the first case. We are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In the second, in isopentane, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in the third case also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the molecular formula of all the 3 compounds is the same. Now if you look at them, there is a clear difference. The first one is a straight chain, the second one is a branch chain. So a carbon that is being attached to the second carbon atom of the straight chain, it is called as isopentane, and the third one we are having what is called as a neopentane. So this is a very unique property of carbon again, okay, it shows different isomerism. At home you can try for hexane, okay, that is C6H14, okay, you can try how many structures you can draw of hexane, okay. Next we are going to move on to the functional group. Now what exactly is a functional group? If an atom or a group of atoms that is being attached to a carbon compound, what it does, it completely changes the property of that carbon compound. So this property, okay, or this atoms or the group of atoms that are getting attached to the compound and changing the property of compound, they are called as a functional group. Now there are different kinds of functional group, but in your 10th standard you are going to learn very few. Okay, so you can see over here the first example, halides. Okay, now halides also called as halo group. Now group 17 of your periodic table, that is fluorine, chlorine, bromine, iodine, okay, these are called as halogens. And why it is called as a halo group? Because when it will be attached to a carbon compound, it is going to end with the letter, with the sound O. Okay, so we will see, we are not going to call it as chlorine. Okay, and this line that is being drawn, it has a purpose because it is going to get bonded to the main carbon compound via a single bond that is being shown over here. Okay, so we are having chloro, bromo, iodo, fluoro, okay, and so on. So it's the name of the compound is going to end with ane. Over here in this case you can see Cl, that is chloro, and CH3, that is methane, okay. So it will be called as chloromethane, Okay, in the second case we are having C2H5Br, so bromoethane. Fine. The nomenclature we will be learning. So as of now you know what are the halo groups called. Okay, they are fluoro, chloro, bromo and iodo. The second functional group that we have is alcohol. Okay, the functional group of alcohol, okay, it first of all the name is going to end with ol and the formula is OH. The bonding to the main carbon compound is going to take via a single bond. So here see your example, it will be pronounced as methanol, ethanol, propanol, butanol and so on. So whenever there is an alcohol group which is being attached to your main carbon compound, the name ends with ol. Third one, we are having an aldehyde. Aldehyde formula can be written in two ways. In the first one it is being written as CHO and in the second one it is being written as C double bond OH and the name ends with al. So when we are doing the nomenclatures you have to remember that if there is a aldehyde group attached then the name of the compound is going to end with al. Okay. So over here we are having methanol, that is HCHO, okay, and over here we are having ethanol, CH3CHO. The formulas that are being given over here are in their condensed form, okay. The structural formula are not written. But remember students, you have to learn these formulas, you have to by heart them, okay. The fourth functional group that we have is called as carboxylic acid, that is COOH or C double bond OH, okay. There is a double bond missing over here, it is C double bond OH. Okay, and its name ends with oic acid. That means when you are going to write the name of the compound, it is going to be carboxylic acid, so oic acid. So here are a few examples. This name is methanoic acid and ethanoic acid. You should be able to identify the functional group that is present in a particular compound. The next functional group that we are having is ketone. Ketone is CO or C double bond O and its name ends with -one. It's not pronounced as one, but it is being pronounced as -one. Okay. So here we are having CH3COCH3, that is prop unknown and but unknown. So you see the presence of various functional group, it changes the property of the compound and so also you have to change the names of those compounds depending on the functional group. Let us have a quick recap of what we have done. We have learned the first part of the lesson, that is the bonding in carbon compound. Carbon compounds are having covalent bonding, that is mutual sharing of electron pairs between two atoms. Next we learned about the allotropes of carbon. Okay, there were three allotropes. See, the allotropes of carbon are crystalline variety and the amorphous variety. What we have learned is the crystalline form diamond, graphite and fullerene. The amorphous variety includes lamp black, charcoal, okay, soot, that we are not going to focus on that. Next we learned about the versatile nature of carbon. The carbon exists in various forms. It is present in most, it forms the backbone of many macromolecules, that is your organic compounds, and it is also present in all the everyday items that we use in our house, from the plastic to the furniture to the food that you eat, okay, everything consists of carbon. So why it's so versatile in nature? There are reasons called as catenation, which is the self-linking property of carbon. After that is the tetravalency of the carbon and also the tendency of the carbon to form single, double or triple bond, or in short I can just say it's the tendency of the carbon to form multiple bond. After that we have also learned about hydrocarbons. Hydrocarbons are compounds that are formed between carbon and hydrogen. Okay, we have learnt two types of hydrocarbons, saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons are also called as alkanes, which are formed by where the linking between the two carbon atoms is via a single bond, whereas unsaturated hydrocarbons are alkenes and alkynes. Alkenes are those in which the carbon atoms are connected via a double bond, and alkynes are the one in which the carbon atoms are connected via a triple bond. Okay. In case of alkanes, the general formula was CnH2n plus 2. In case of alkenes, it was CnH2n, and in case of alkynes, it was CnH2n minus 2. Okay. Besides this, we have also learnt about how isomerism occurs in case of hydrocarbons, and how there are different formation of even though the molecular formula is same, how the structure differs. Okay, so we have learnt about the structural isomerism in case of hydrocarbons, and then we have learnt about different functional groups. As you can see, it is being mentioned over here. Okay. So students, for today's class, I hope you have grasped whatever I have given. Please don't forget to do your homework, that is draw the different structures of hexane, that is C6H14. Thank you, and I will see you for the next class.